All right, let's look at a surface area problem. This is number 15 from 8.2. And they're giving us this formula in terms of x, so it's x equals. It does have an a in it, which is just a constant. So that a is something like 5 or 100 or something. And if you don't recognize this formula, it happens to be the equation of a circle, right? It's x squared plus y squared equals r squared, or a squared. Just solve for x. And because it's x equals the positive square root, that's what this symbol means, is not the plus or minus, but just the plus. Because it's x equals the positive square root, you're just getting 1/2 of the circle where the x values are positive. And if you don't remember the formula for rotating around the y-axis, keep in mind when we rotate around the y-axis, then our radius of rotation is right there, which is x. So the formula looks like 2 pi x and then a little ds, which keep in mind ds is a little bit of arc length, which is calculated with the arc length formula from the previous section. So it looks like that. Okay. So let's see what we can do about setting this integral up. We do want to, for surface area, we do want to integrate 2 pi x, but notice we're going to have a dy integral, so we don't want an x floating around there. We want x rewritten with some y stuff. Unfortunately, we have that. We've got a squared minus y squared. So that's just so we've got the 2 pi and we've got the x. We still need to get the ds in there. Let's go ahead and put the limits of integration on also. They didn't really notate that in the formula, but we are going from 0 to half of a, whatever a is. So if it looks like in my picture I use 6 for a, so we're going from 0, 1, 2, 3. We're covering this much of it. Okay, so the last thing we need then is this ds expression. So that'll be the square root of 1 plus. And then we need the derivative of the x function in terms of y squared. And then we have a dy on the end. So let's see if we can figure out what goes in there. We need the derivative of x. Treating y like the variable. So this thing, let's just put this in calculus friendly form, is a squared minus y squared to the 1/2. So when you take the derivative of that, it's chain rule. The 1/2 comes down. A squared minus y squared stays in there. You get negative 1/2. And then chain rule also says, and the derivative of what's inside. Keep in mind a squared is constant. Its derivative is 0. The variable is y, so the derivative of the inside is just negative 2y. There's a 2 there and a 2 there that can cancel. So this thing ends up being negative y over the square root of a squared minus y squared. All right, there's the integral. It's set up. Looks ugly, but it fortunately is going to simplify for us a little bit. Particularly having a squared and some square roots right here will be helpful. So let's see what we can do as far as simplifying this. I'm going to pull the 2 pi out front since it's constant. So we'll go 0 to half of a. We've still got this square root of a squared minus y squared. We've still got the square root of 1 plus, now let's see what this stuff gives us. That's y squared. And on the bottom is a squared minus y squared. It still isn't perfectly simple, but you might be starting to feel a little bit better about this, particularly if I think about getting a common denominator inside the square root here and adding these two things together. So let's get a common denominator. So this will be a squared minus y squared over a squared minus y squared. Squeezing that in there. And now think about it, as we add these together, the y squares cancel. And we have the square root of a squared minus y squared. And the y squareds cancel again, so just a squared on top. And actually, I'm going to, hopefully that's not too many steps in one. On the top, we just have a squared, and then the square root of a squared is just a. Okay. On the bottom, there's two terms, so I can't simplify the root. It's a squared minus y squared dy. Fortunately, though, I don't really need to simplify the root, or it's better not to, because that term and that term cancel each other completely. And I'm starting to smile because this integral is starting to seem like an integral I might not need crazy calculus skills for, because it actually just simplified down to a dy. So keep in mind, again, a is a constant, so when you integrate any constant, like if you integrate 5, you get 5x. Or if the variable is y, you would get 5y. So when it's a, we're going to get ay. So we're getting 2 pi times a times y, evaluated from 0 to half of a. When I plug those values in, I get 2 pi a times a over 2 minus, and then plugging the other term in, there's 0, and that collapses the whole term. So I end up getting, the 2's cancel, I get pi a squared. And of course, that does depend on the value of a, which it should, depending on how big our circle is. And we're done. If you happen to remember the formula for the surface area of a sphere, because that's what we're looking at here, you may be able to verify this with that geometry formula. We've done 1/4 of the full span of a sphere. And this is 1/4 of the surface area of a sphere. But even if you don't know that, that's fine. We have our answer here. And we are done with problem 15.